Let's take a look at this really cool problem in the homework in the implicit differentiation section. The function given this time was 5xy plus 3x to the 3 over 2, y to the negative 1/2 is equal to 44. We're supposed to find the derivative implicitly of that relation, and then we're supposed to use our answer to find the slope of a curve at the point 4, 1. Okay, so first thing I would strongly recommend doing as you write down the problem, make sure you understand where you're going to have to use the product rule. So instead of just writing 5xy, I wrote it as the differentiable function 5x times the differentiable function y. And then the second part there, again, it's a product. It's 3x to the 3 over 2 times y to the negative 1/2. Okay, so when I took the derivative of that first term, product rule, derivative of the first is 5 times the second, that's where the y came from, plus the first, 5x, times the derivative of the second. Unlike x, whose derivative is 1, because dx is 1, I don't know what the derivative of y is. In fact, I'm solving for it. So whenever I say the derivative of the second, I just have to leave it dy dx. I move to the second term now, and I take the derivative of it. Derivative of any product is the derivative of the first term. Derivative of 3x to the 3 over 2 is going to be 9 over 2x to the 1/2 times the second plus the first, now times the derivative of the second. Derivative of y to the negative 1/2 is going to be negative 1/2 y to the negative 3 over 2. I subtracted 1 from the exponents. And then you say times the derivative of what was on the inside of this power. It was a y. So the derivative of y is, again, dy dx. On the right-hand side, derivative of any constant we know is always 0. So now at this point, when I need to solve for dy dx, the way I do it is I just say, okay, gather all dy dx terms, and there's only 2 of them on the same side. So I went ahead and gathered these on the left, and notice what I went ahead and did. The whole purpose for gathering these on the left-hand side is to eventually factor out a dy dx and solve for it. So why not go ahead and factor the dy dx out as you're doing this first step? So I can say, okay, the dy dx terms on the left, what's going to have the other terms in there other than dy dx in your first term? Well, 5x. So I get dy dx times 5x. That would give me that term. Now my other term over here, when I factor a dy dx out of it, I'll get minus 3 over 2, x to the 3 over 2, y to the negative 3 over 2. That's where that came from. And again, the dy dx is factored out in front of that group. Now, since I have my dy dx times all of the terms that had a dy dx on the left, I need to move every other term to the right. 5y moves to the right, becomes negative 5y. The 9 over 2 x to the 1/2 y to the negative 1/2 moves to the right, again, becomes negative. Okay, so now it's easy to solve for dy dx. I have dy dx times this group is equal to this group. So dy dx is equal to what I had over here on the right in the numerator divided by what it was previously multiplying in the denominator. Final answer for dy dx, you could clean that up by getting rid of the fractions and maybe getting rid of the negative exponents. There's no reason to do that though. This is a perfectly fine derivative answer here. Now for the second part, it wanted us to find the slope of the curve at the point 4, 1. Well, the slope is just your derivative gives you your slope formula. That's what I was trying to say. So I know derivative is an instantaneous rate of change. I just need to evaluate that instantaneous rate of change when x is equal to 4 and when y is equal to 1. Unlike earlier problems where we only plug the x value in, we'll need both of the coordinates here. And start plugging those in. In my numerator, negative 5 times y is negative 5 times 1, minus 9 over 2 times x to the 1/2. Well, that's 4 to the 1/2. That means the square root of 4. Well, square root of 4 is 2. Times 1 to the negative 1/2, 1 to any power is just 1. I get the numerator done. My denominator, 5 times x becomes 5 times 4, minus 3 over 2 times 4 to the 3 over 2 power. Well, 4 to the 3 over 2 power is 8 because that's asking you what is the square root of 4, which is 2, and then cube that. 2 cubed is 8. So 4 to the 3 over 2 power is just 8. And then for my last term, again, 1 to any power is just 1. Simplifying this out in the numerator, you'll have negative 5 minus 9. Your denominator is going to be 20 minus 3 times 4. So 20 minus 12. I got negative 14 over 8 when I simplified that down. The slope of the tangent line to the curve at the point 4, 1 has to be negative 7 over 4. That's a beautiful problem. I really like this one.